Welcome to VFD Vibes, your place for all things related to variable frequency drives. If you're interested in how to make things turn, or manufacturing technology in general, then this is the place for you. I'm your host, Greg Weichman, and today we're doing something a little different. No guests this time, just me diving into a topic that every VFD user, installer, and sales professional should know: how to get the most out of your VFD. Today's episode is inspired by an article written by one of my colleagues, Paul Avery. He is one of Yaskawa's Drive's technical training experts. Paul's piece, How to Get the Most Out of Your VFD, breaks down what happens beyond the purchase, how to install, maintain, and optimize your drive for the best performance and energy efficiency. I'll be walking through those insights and adding a few of my own along the way. Before we dive in, just a quick note, this episode will be a high-level overview of the key concepts. If you'd like to explore these topics in more depth, you can find additional details in other VFD Vibes episodes and at yaskawa.com, where you'll find articles, training resources, and technical guides. So let's get started. We all know that VFDs save energy. That's not any kind of breaking news. By adjusting motor speed to match demand, you're cutting power, consumption, and ultimately saving money. But if it were as easy as slapping a drive on a wall and calling it a day, this would be a short episode. The truth is, getting the most out of your VFD takes planning, setup, and maintenance. Think of your VFD as part of a larger ecosystem: motor, cabling, load, and environment. Each of those elements can either boost your efficiency or quietly drain it away if overlooked. A properly installed VFD can last for decades, especially with Yaskawa's quality. But a poorly installed one can fail long before its time. So let's start with installation. Proper installation isn't glamorous, but it's critical. It's like the foundation of a building. If it's off, everything else will be too. Using factory-trained installers makes a world of difference. They know what to look for. Things like high ambient temperatures, long motor leads, and even power factor correction capacitors that can cause early VFD failures. Many manufacturers, including Yaskawa, offer extended warranties for installations performed by certified technicians. That's because proper installation doesn't just protect the drive, it ensures safety, reliability, and long-term ROI. A well-installed drive can operate for years without major issues, but there's more to it than wiring. The next two pieces of the puzzle are the motor and the motor cable. Let's talk about the motor first. You need to make sure it's built to handle the PWM voltage a VFD sends out. Voltage coming from the electrical grid is a nice clean sine wave. But if we remember how a VFD works, it takes that AC voltage, rectifies it into a DC voltage on the bus, and then recreates a sine wave on the output or inverter side of the drive. That is a simulated sine wave that we refer to as pulse width modulation. And in doing so, it is actually turning the voltage on and off from that DC bus very rapidly, and this causes little spikes in energy as they travel down the motor leads and get to the motor. This is why we need to worry about the insulation that the motor has. Older motors might not have the right insulation systems, which means they could fail early as they see all of these little PWM voltage spikes, especially if you've got long motor leads. If the motor leads run over 100 meters, it's a good idea to add an output reactor between the drive and the motor to help protect it from these voltage spikes. Yes, it will slightly reduce efficiency, but it's well worth it for the extra life you'll get out of the motor. And while we're on the subject of motors, bigger isn't always better. What if I just pick the largest motor out there? I'll pick one that's bigger than what I need for my system. That way I don't have to worry about damaging it or overloading it. While that might seem like a safe choice, it ultimately hurts your system's efficiency and will cost you more money operating it over the years of its life. Undersizing isn't ideal either, but a properly sized motor gives you the sweet spot between performance, longevity, and efficiency. When selecting motor cables, keep in mind that long lead lengths can cause voltage reflections. The fast PWM voltage pulses from the drive can reflect off the motor terminals due to impedance mismatch, sending part of the energy back toward the drive. These reflections can lead to voltage spikes at the motor terminals and along the cable. The longer the motor leads, the greater the voltage reflections from those PWM spikes. These reflections create points where the voltage pulses bounce back, increasing stress on the motor's insulation. To reduce this stress, a DVDT filter or load reactor can be installed between the drive and the motor. These devices help smooth out the voltage waveform and limit the rate of voltage rise. The term DVDT simply means the rate at which voltage changes, how quickly it rises and falls with each switching pulse. Versus other parts of the world, drives that are designed in Japan, such as Yaskawa, often use a higher speed switching device that produces a higher DVDT rate. This improves the drive's internal efficiency by reducing switching losses. One of the next important things to do might surprise people who think installing a drive is a plug-and-play deal. Auto-tuning is your drive's way of learning its motor. It helps build a precise internal model of how the motor behaves, resistance, induction, slip, all the good stuff. Without it, the drive is just guessing. Run the auto-tune with no load attached, otherwise your measurements will be off. And it's best to do when the motor is at a normal operating temperature since resistance changes with heat. When done right, the proper auto-tune can reduce current draw for the same speed and load, meaning more torque per amp. Or in simpler terms, better performance with less power, and at the end of the day, that means a cost savings on your utility bill. Now that your VFD knows your motor, let's talk about how it behaves under changing conditions. Many systems don't run at full load all the time, so how do we keep efficiency up when the demand drops? This is where unique product features like energy savings mode come in. It's essentially the opposite of torque boost. Instead of adding voltage to create more torque in times of need, energy savings mode reduces voltage during light loads to minimize power draw. Great for fans and pumps that don't always need full speed, and again, great for the longevity of your equipment. Then there's the sleep function. Imagine a pump application where demand drops to almost nothing overnight. Rather than spin at low speeds wasting energy, the drive goes into a sleep mode, staying alert but not actively driving. When demand returns, it wakes up and automatically gets back to work. Simple, smart, and efficient. Once again, saving you power and money. When we talk about wasted power, something a lot of people overlook is vampire power. That's the electricity your drive still consumes when it's not even running. Like your TV that draws power in standby mode, VFDs can still pull current through the rectifier and capacitors even when idle. Some manufacturers, Yaskawa included, address this by offering features that use a small auxiliary DC supply to keep the brains of the drive alive while disconnecting the main power input. When a run command comes in, the drive wakes instantly without wasting idle energy in between. That might not sound like much for one small drive, but imagine a high horsepower large drive, or a facility that might have hundreds of VFDs. That can add up to a real savings. Now that our drive is running, let's shift gears. How do you keep it that way for the long haul? The short answer is, keep it cool. Heat is enemy number one for any drive. It comes from two main sources, the environment around the drive and the current flowing through it. Modern drives use IGBT modules, insulated gate bipolar transistors, to create that PWM output waveform that we talked about before. These modules have built-in thermistors so that your drive can actually tell you how hot it is. Most drives will show that temperature on the keypad or through your network connection if you are using the data registers and connecting your drive to a PLC or SCADA or intelligent supervisory system. But remember, drives can't cool below ambient temperature. Managing your environment is step one in preventative care. Beyond that, there are several ways to keep your drive cool and protect it from excessive heat buildup. You want to ensure proper ventilation and airflow in electrical panels and drive enclosures. Use cooling fans or air conditioning units in control rooms where ambient temperatures tend to rise. Up here in Wisconsin, I know a lot of facilities where in the winter they can simply blow in external air and get free cooling. However, I've been in those same facilities in the summer with no air conditioning, and the ambient temperature in the room is 90 to 100 degrees, and inside the panel, it's well above 100. One of these facilities I speak of I was in during the summer, and they were complaining of electrical equipment failure. It didn't take more than a quick walk out to that space to realize what was going on. We were able to recommend some electrical panel heat mitigation techniques, and ultimately they ended up getting a lot more life out of their equipment. You also want to maintain clearances around your drive to allow for the proper heat dissipation. If you look in the manual, each model of drive will tell you what the proper side-to-side and top and bottom clearances are to allow that heat to properly dissipate. Many of the Yaskawa drives actually allow for zero stacking, which means you can place them right next to each other and they are still able to properly dissipate their heat. Consider heat exchangers or filtered forced air systems for dusty or oily environments. And you want to periodically inspect and clean vents, ducts, and fans to prevent dust accumulation that restricts airflow. Even simple steps like keeping the enclosure door closed and the room temperature controlled can extend the life of a drive as well as your other electronics dramatically. A lot of the ways to keep heat in check should be incorporated into a maintenance plan. Here's a solid checklist for preventative maintenance. Each of these will help prevent small issues from turning into big failures. Heat sink cleaning is simple but critical. Keep the fins clear of dust or oil buildup so air can flow freely. This is where the majority of the heat is dissipated from the drive, so this is a critical step. Filter maintenance is especially important on UL Type 12 enclosures that rely on filtered airflow. The filter is there to keep the air clean in the panel, but to do so, it removes particles out of that air, and as those build up on the filter, the ability for air to flow freely through the filter gets reduced. You need to make sure you're properly cleaning or replacing those filters on scheduled maintenance. And if the filter has even a small tear, it's time to replace it. Don't patch it, don't put duct tape on it, and hope to get another year out of it. Fan checks. Make sure that airflow matches design specs. And many drives have sensors that trigger a warning if a fan slows or fails. Make sure to check your drive for these warnings, or again, if your drive is networked up to a PLC or supervisory system, it's a great data point to monitor so that your SCADA system or an HMI can tell you when you might have a fan failure on your VFD. Doing load checks on the drive can tell you if it's being overworked. Too much time in overload can shorten the life expectancy. Your connection points get hot, the drive internals get hotter than normal. When we talk about working in overload, it's meant to be for short spans when extra torque or power is needed. The drive isn't meant to live in that mode, otherwise your drive is probably undersized. And finally, I talked about those connections. You should be doing connection checks. Loose terminals cause resistance, which means heat. And heat, as we said, is the killer. Some maintenance teams use thermal imaging to find hot spots before they cause damage. So you don't have to go to every panel and power it down and check to make sure all your screws, bolts, and lugs are tight. You can actually shoot it with a thermal imaging camera, and if your connection points are hotter than they're supposed to be, that's a good sign that you've got a loose connection. Even if you do everything right, the best components will wear out with time. Fans, capacitors, relays, they all have service lives. Modern drives now include life monitors that estimate the component wear and alert you before a failure occurs. The best way to use these monitors is so that you can plan to replace these parts during scheduled downtime. When a production line is already going to be down, you're not incurring additional downtime or wasted production time to do your VFD maintenance. What you don't want is the line to have an unexpected down because your VFD fails because you didn't do a good job with your maintenance. Looking ahead, artificial intelligence, or AI, is beginning to play a role in preventative maintenance. Imagine a drive that analyzes trends in current, temperature, and bus voltage to predict failures before they happen. That future is coming and faster than most people think. I could see this being implemented a couple of different ways. Some of this could live directly in the drive, and some of this could live in that larger supervisory or SCADA system. So when your drive has that network connection and it's able to share its data and its monitors with that system, the system can use its own AI to characterize that drive, know what it should be running like in normal conditions, and tell you when things start to differ from the norm. I think this will be a really cool future. When I started in the industry, things were pretty much purely preventative maintenance, which means You had a component that was meant to last so many hours, and when its lifespan was up, you replaced it. If that device was running really well, you might have replaced it weeks, months, or years before it needed to be replaced, which means you wasted money. If that device wasn't properly cared for or wasn't manufactured well, it could actually die before its stated life, and that caused the unexpected downtime I just talked about, which can cost companies a lot of money and lost production. Imagine automation systems where they can actually tell you when a component is going to fail so that you can get the absolute most out of that device. You don't waste any of its useful life, but it never fails unexpectedly on you. You were able to tell that it was failing, and you were able to schedule it down and take care of it without disruption of your process or possibly damaging other equipment. I think that is a pretty cool point to strive for in our modern manufacturing. So to wrap things up, installing a VFD is just the beginning. To get the most out of it, focus on proper installation, especially by trained personnel, motor and cable matching, auto tuning to get that accurate model of the motor and the best accurate and efficient performance you can. Drive features like energy savings modes and sleep functions. And remember to keep your preventative maintenance up to date and on schedule, and to keep that heat under control. Do all of that and your drive will not only save energy, it'll serve you reliably for years to come. A huge thanks again to Paul Avery for writing the original article that inspired today's episode. You can find it on Yaskawa's website under the title, How to Get the Most Out of Your VFD. And that's a wrap for this topic. If you enjoyed today's episode, please like or follow this podcast to stay informed when new episodes launch, and if we're doing a great job, please leave us a 5-star review. Thank you for joining us, and as always, we'll see you next time on VFD Vibes.